This video is a preview of Lab 2 Flood Frequency Analysis for Natural Disasters class. There's 3 relevant documents associated with this lab. The first one is the instructions, the second one is the data set that will be used, and the third one is a piece of graph paper that you can print out and use to graph your data to get the answer. Let's look at the instruction sheet. The first section of the instruction sheet is just an overview and a generalization about why do floods happen and why is it important to study them numerically. The second group of information here reviews what is stream flow, discharge, and gauge height. Flow rate is equal to the area, which is width times depth times the velocity. And also a reminder that the gauge height is another way to measure a flood by measuring the elevation of the water surface. It's very notable that flow rate can increase tremendously with a small change in gauge height, because if the water goes a little bit higher, the water level goes higher, it can flow through a much larger area as it rapidly expands into the floodplain, and we'll see that later. This is just information, this simple bit of information just for completeness defines the river that we'll be studying. Using the spreadsheet, which looks like this, we're able to make some computations and some analysis of the data. One thing you may not be familiar with is that it is possible to sort a data set in Excel first by clicking and dragging to select the whole data area and then asking for the sort function. And why don't we start by sorting from largest to smallest. And what it's just done is it's sorted according to sorted by the date. So let's just pick that column and we'll sort largest to smallest by the flow rate and see how that behaves. It says expand the selection. I'm going to go ahead and do that, and it just did that for me. It just sorted all of the values from the largest discharge to the smallest, from 2 to 3,400, and that in fact will answer several of the questions that are asked in numbers 1 and 2. Let's go look at the spreadsheet again and see what other answers we can come up with. It also asks to look for a relationship between, one of the questions asks to look at the relationship between gauge height and discharge, and we can see in this case that going from 300 and some as a discharge to 3,000 and some as a discharge, the gauge height only increases from 5 to 12. So the water level doesn't increase too much, and then the stream flows into the floodplain and has a much larger cross-sectional area and has a much larger discharge. So the answer is no, the relationship between these two is definitely not linear, even though discharge does increase as gauge height increases. It's convenient to have the data sorted in this way. And the average, we can also calculate the average using the spreadsheet without having to do too much work. We can select, actually what we can do is we can pick a cell. It's almost a lesson in spreadsheeting. We can pick a cell here and type equals average of, and now all we have to do is go and select all of the discharges right there, and it's looking for me to close the parenthesis, and I do, and when I hit check mark it tells me the average is 248.32. So that was, well, I guess that's part of the answer right there. That was very convenient. Another thing that we'd like to do for the next part of this lab, in which we actually compute the recurrence intervals, it's convenient that this is already sorted, so we can fill in part of the table very easily and then apply the formula that we learned in lecture, where a recurrence interval, also called a return interval or a return period, is equal to n plus 1, and we have 43 years of data, so every calculation you do, the top of the fraction will be 44, and then M will be the rank of the flood. So that's the calculation. What's shown here is doing the calculation for the biggest storm. It's always going to be 43 plus 1 divided by the rank, giving us 44. And we can see in the spreadsheet that that's already been filled in. Using number 2, I think I've missorted the list a little bit in my experimentation, but just ignore that. For number 2, that is definitely correct. Number 2 shows is 22 years as a return period. Again, applying the formula, 43 plus 1 is 44, divided by 2 equals 22. The last part of this lab is going to be the process of plotting all the data, and there will be 43 points to plot, but they'll go pretty quickly. And once that's done, you'll be able to draw a straight line through all the points and then read off the rest of these answers from the graph. And the last two are a little more thought-provoking, and I welcome you to send Mr. Bohm or myself a note asking how this might be done, or ask a question in class. One thing I should note before I close this video is this is a kind of a strange piece of graph paper. It's constructed so that the data from flood data will plot as a straight line. This is a logarithmic scale on both axes. It's weird, but the numbers are in order, and you plot 30 to 40, and 35 is in between, etc., and 10, 15, 20, 30, 40, 50. So it looks weird, but it can be plotted in ways that you're familiar with.